Hello everyone, this is Arthur Morris and welcome to Graphing Linear Inequalities. Okay, to graph linear inequalities, we're going to use the same method as what we use to graph just straight lines, linear equations, using the slope-intercept method. So again, to use the slope-intercept method, you want to solve the equation for y to get it into y equals mx plus b form. After solving the equation for y, you want to identify and plot the y-intercept. And then we need a couple of more points, so we want to identify and use our slope as rise over run to find a couple of more points. Remember, the slope gives you directions on how to get from point to point on a line. Now here's where it changes a little bit. We have to remember that inequalities can have several solutions. For example, if I just had the inequality of x is greater than 5, then that could be 6, 7, 8, 9, 10, and so on. So to show this, we have to use a solid or a dashed line, depending on the inequality that we're given, and also shade on one side of the line or the other to show where all of our solutions are located. So if y is less than or equal to or greater than or equal to, the key part being there, or equal to, then we draw a solid line like we have with the y equal equations. However, if y is just less than or greater than without the equal to bar underneath it, then we draw a dashed line through the points. Now, to determine which side of the line to shade on, we pick a test point. We pick a point, plug it in our inequality to see if it's true, makes a true statement or not. If it makes a true statement, then everything over there on the side of that point is also true. That would be the side that we shade on. However, if I plug in that test point and it makes a false statement, then none of the points on the side of the test point are true. All the points on the opposite side of the line would be our solutions, and we would shade on that side of the line. So the easiest test point to use is 0, 0, as long as your line does not go through that particular point. So we pick any point that's not on the line, plug it in our inequality. If the statement that we have after we simplify is true, then we shade everything on that side of the line of the point that we picked. If it's not true, then we shade everything else on the opposite side of the line. Now, an alternative to that is to use the less than or greater than and determine where to shade. If we have y is less than, then we're shading below the line. And it's easy to go to the y-intercept and move below the line, and that'll tell you which side to shade on. Or if we have y is greater than whatever else, then we shade above the line. Again, you can go to the y-intercept point, go above that y-intercept, and that would be the side that you would shade on. Okay, so let's take a look at a few examples here. All right, this first one we have y is less than 5x minus 2. So we already have this in the y equals mx plus b form. Now, the first thing that I notice is that I do not have the or equal to bar here, so my line will be a dashed line when I make it, because I do not have the or equal to bar. So my y-intercept, -2, or the coordinates 0, -2. My slope from that first point is 5. For graphing purposes, we want rise over run, so we want it in fraction form, so 5 over 1. That tells me from my y-intercept to go up 5 places and to the right 1 place, and plot my next point. And then we could plot another point if we chose to. Again, we could go up 5 places from this point and to the right 1 place and plot another point. Now, since I do not have the or equal to bar, I would have a dashed line. Now I have to determine which side to shade on. Now I can use the test point method, or I can look at this and see that it says y is less than. With y is less than, then if I go to my y-intercept and go less than or underneath it, then I see that I end up on my right side of my line here. So everything on this side of my line should be my solution. However, let's pick a test point. And the easiest test point to use is 0, 0, as long as your line doesn't go through it. So let's test 0, 0 in our original inequality to see if it makes a true statement or not. So simply replace y and x with 0. So now I get 0 is less than 5 times 0 is 0, negative 2. 0 is not less than negative 2. That is false. So the test point of 0, 0 that I picked is not true. So that tells me that everything on the opposite side of the line of 0, 0 would be true. So that is the side that I shade on. Okay, so what if we have 2x plus y is greater than or equal to 7? 2x plus y is greater than or equal to 7. Well, first of all, I have the or equal to, so that's a solid line because I have the or equal to bar. Solid bar underneath the inequality, solid line. However, I need to solve this equation for y, so I'm going to subtract 2x from each side. So now I have y is greater than or equal to negative 2x plus 7. So now I should be able to identify my slope and my y-intercept. My y-intercept is 7, or the point 0, 7. My slope is negative 2 for graphing purposes. Again, I want that in fraction form, so negative 2 over positive 1. Which tells me that I will go down 2 places and to the right one place after I plot my first point. So let's see here. 0, 7, down 2 to the right 1, down 2 to the right 1. Again, I had the or equal to bar underneath my inequality, so I have a solid line. Now, determining where to shade from, I look at the equation or the inequality where I have y by itself, and it says y is greater than or equal to. So if I go greater than, or if I go up above my y-intercept point, I would end up on the right side of the line again. So again, everything over here should be shaded. Let's pick our test point of 0, 0, plug it in, and see if it makes a true statement or not. And you can plug it in the original or where you solved for y. I will just plug it into my original equation. So 2 times 0 plus 0. 2 times 0 is 0 plus 0, 0. 0 is not greater than or equal to 7. So again, nothing on the side that 0, 0 is on would be true. Everything on the opposite side, all the points on the opposite side of the line would be my solutions, including the points on the line. Okay? Now what if we have negative 5x plus 2y is greater than 20? I'll change this here. Let's make this positive 5x plus negative 2y is greater than 20. 5x minus 2y is greater than negative 20. So 5x minus 2y is greater than negative 20. All right, so let's subtract 5x from each side. So now I have negative 2y is greater than negative 5x minus 20. And then divide both sides by negative 2. Now remember, we are dealing with inequalities. And when we divide both sides by a negative, we have to remember to flip our inequality symbol. So that becomes y is less than 5 over 2. Negative over negative again makes positive 10. So my y-intercept, 0, 10. My slope, which is already in fraction form, 5 over 2. Plot our y-intercept point. Now I don't have enough room to go up 5 and to the right 2, so I can always go the exact opposite. In this case, down 5 and to the left 2. And again, I can do that from here, go down 5 places and to the left 2 places. Now I did not have the or equal to bar, so that tells me that I should have a dashed line. Then I have to determine which side to shade on. Well, again, you look at the y, where you solve the equation for y, or inequality for y, to determine that. So it says y is less than, so if I go to my y-intercept point, less than the y-intercept right here would go underneath it down, so that tells me that I should be on this side of my line. Let's pick a test point, and the line does not go through 0, 0, so we will test 0, 0 again. And our original right here, 5x minus 2y is greater than negative 20. So 5 times 0 minus 2 times 0 is greater than negative 20. Anything times 0 is 0, so I get 0 is greater than negative 20, which is true. So that tells me that everything on the side of the line where 0, 0 is should be shaded. Okay, now your two special graphs. X is greater than negative 4. Let's take a look at this one first. We don't have the y variable in there, so that tells me that's one of my special lines. Remember, if we just have x equals a number, that is a vertical line crossing the x-axis at that particular number. So to graph x is greater than negative 4, first of all, I don't have my dashed line underneath there, or I don't have my or equal to bar, so I have a dashed line crossing negative 4 on the x-axis, a vertical line there. Now it says x is greater than negative 4. Well, we either have to shade to the right or to the left. So greater than negative 4 would be the numbers to the right of negative 4. So a dashed line and shaded on the right-hand side. Now what about y is less than or equal to 7? Well, we have the or equal to bar in this one, so that is a solid line. Solid line underneath the inequality, solid line. Y equals a number gives us a horizontal line crossing the y-axis at that particular number. So we would go to 7 on the y-axis and draw a horizontal line. Now my inequality says y is less than. I either have to shade above this line or below this line. So think about where less than would be. Less than is going to be below. So all the points down here would be solutions for this inequality. Okay, I hope you found this video to be helpful. Thank you.